Hi guys, in this video we are going to continue on Unit 4 of Form 3 Chemistry, and last time we did talk about a lot of chemical reactions related to calcium compounds. This one we call it calcium cycle or the limestone cycle, alright? And today actually we will talk more about calcium carbonate, but this time we will talk more about its properties and its application. All right, and there will be less chemical reaction involved, more of a daily life related. So it should be more manageable when compared to the previous one. So let's take it easy and let's go ahead and have a look. Now here, first of all, we are trying to discuss the formation of chalk, limestone, and marble. Now, if you remember, all of these stones or rocks, they actually referring to mainly calcium carbonate. So basically, they are different form of calcium carbonate or different rocks that consist of calcium carbonate. And the first thing we're going to know is what are the difference and why we have three types, like how are they being formed in the nature. So now before we go into these notes, I would like to play a short video, and on that I will elaborate more, and then we will go back to notes here. Okay, so let's have a look at the video.
Millions of years ago, the shells and skeletons of many dead marine organisms have fallen to the seabed. Over the years, these deposits have become thicker and have been compressed by many more layers of sediment to form limestone. As mentioned in the introduction, limestone is a type of sedimentary rock with a high percentage of calcium carbonate. Limestone has many uses and real-life applications. It has been used to carve many structures and even to construct buildings.
All right, so there is just one remark related to the video. So just now we see how the chalk, limestone, and marble are formed in the nature. So first of all, you see all of these are the aquatic organism. So the living things live in the sea. When they are dead, of course, the soft tissue, the flesh, will be decomposed, but the shells, the bones, they were still there. And those shells and bones contains huge amount of calcium compound, mostly calcium carbonate. So those shells and rocks, they sink to the bottom of the seabed, and they will soon get covered up. Okay, obviously when you get more and more that remains, and then sooner or later they will be covered up by the soil or the mud deep under sea. And with more and more soil and mud on the top, then this layer of calcium compound is exposed to higher temperature and pressure. It takes millions of years. Then those calcium carbonate or the calcium compound will be converted into chalk. Okay, and with more and more layer of soil or layers of calcium carbonate covered at the top, that means this particular layer is buried deeper and deeper underground. The deeper it goes underground, the higher the temperature it will be exposed to, as well as the higher the pressure it will be exposed to. So in that case, the chalk may convert it into limestone. And as you can predict it, with even higher temperature and pressure, the limestone can be converted into marble. Okay, so this is basically how the marble, limestone, and chalk are formed in the nature. And do remember, this process takes millions of years to accomplish. Okay. All right, so now you understand the whole picture of the formation of chalk, limestone, and marble. So now let's just put down the notes for our revision. So here, calcium carbonate exists in nature as chalk, limestone, and marble. Million years ago, the ancient. So here we are talking about the aquatic organism. Aquatic organisms. Basically, aquatic means they live in the ocean, they live in the sea. Organism means living things. Now, of course, if you think this phrase is too difficult, you can always say ancient sea animals and plants. Okay, ancient sea animals and plants. And when they died, their dead remain. okay, the dead remain or the dead body or the corpses, right? The dead remains will be buried under the seabed, okay? And under high temperature and pressure, so here we say that no matter it's animals or plants, for animals, they have bones and shells. For plants, they also have calcium carbonate inside. So here we will focus on the calcium carbonate, okay, or the calcium compound, okay, because like it may exist in different forms. So we will put down the calcium compound in the bones and shells. Okay, you can also put down carbonate. It doesn't really matter though. Okay. So well, the dead remains became what? They will first became chalk. All right, became chalk. So if they are even exposed to higher temperature and pressure, then the chalk will get more compact, get more dense, and the structure also change a bit. And this time, the chalk will become limestone. Okay? And if you provide sufficient temperature and pressure, so the limestone again getting more packed, getting harder, and at the end they become marble. Okay, marble. Right? So that's the idea. So you see, actually the formation of chalk, limestone, and marble are pretty much the same. It's a matter of the temperature and the pressure which the calcium compound is exposed to. Okay? So you will also expect to see marble being digged out deepest underground, and chalk should be on the surface of the layer of the soil. Okay? Because you know the deeper it is, the higher the temperature and pressure the compound is exposed to. All right, and you can also realize that it will be more difficult to extract marble when compared to the other two, obviously because it is deep underground. Okay, that makes a lot of sense. Now, because of being formed under high temperature and pressure, so marble becomes very compact. And it turns out that marble is the hardest among the three, and the chalk is actually the softest. Now you can actually tell the chalk, the one your teacher used to write on the blackboard, that one is called the chalk as well. And you can easily break a chalk. So a chalk is considered the softest among the three form of calcium carbonate. And marble, some of you, if you are rich, okay, at your home, you may have marble platform in your kitchen or marble dining table, right? You can tell they must be very, very strong. It's hard to stretch. It's hard to leave a scratch on top of those marble tables, okay? Now, down here, we will talk more about the uses of the calcium compound. Now, first three, you can tell, again, they are calcium carbonate. But based on the different type of rocks, they have different uses. So first of all, chalk, because it is soft, it can be used as blackboard chalk pen, okay? Blackboard chalk pen. Now, limestone, usually it is used as a building material. Concrete consists of calcium carbonate plus other substance. The reason why we use limestone is because it's strong and it has no fire hazard. Now, when it comes to building, usually we have three different materials: wood, limestone, and iron or metals. Okay, and different material have different advantage or different uses. And you can tell wood has a problem of like if fire breaks out, then the wood will get burned. But it is not the case for limestone. So like this is one of the advantages of using limestone for buildings. But of course it has another problem, another issue. We will talk about it later. Now here we have powdered limestone. So if we have powdered limestone, we can use it to neutralize acidity in soil. So usually plants, they prefer the soil to be a little bit acidic because in that case they can absorb more minerals. But if the soil gets too acidic, probably because of acid rain or any illegal treatment of sewage, something like that, then the soil may become too acidic. In that case, the farmers, the agriculture person, may try to neutralize the acidity by adding powdered limestone. Okay? Now, marble, on the other hand, because of the scarcity, right? It's not very easy to extract, and we don't have a lot because it requires extra high temperature and pressure to form, as well as the because of the beautiful appearances. Okay, marble usually have very good looking surface, smooth surface with some kind of marbling or pattern on it. So usually they are used for decorative materials, using for like furnitures, something like that. Okay. Now, even though marble and chalk, they are both calcium carbonate, but you don't expect to use marble for neutralizing acidity in soil, right? So just that makes a lot of sense. You don't use expensive substance, right, to just neutralize the acidity in soil. Now down here, quicklime, if you remember, calcium oxide. One of its applications is to neutralize acidity in soil. Actually, slate lime as well. Okay. So you see there are 3 different calcium compounds that can be used to neutralize acidity in soil. Okay, there are more applications for quicklime and slate lime. For example, because these 2 are able to react with acid, so they can also be used to remove acidic gas. Okay, in exhaust fume from factories. So a lot of factories, they will produce acidic gases because factories requires electricity to operate, and one of the common ways to get electricity is to burn coal, right? Burn coal. When you burn coal to generate electricity, you also produce a lot of acidic gas, such as sulfur dioxide and sulfur trioxide. So quicklime and slate lime can be used to capture or to remove those acidic gases so that less acidic gases will be emitted out to the surrounding. So it reduces the chances of having acid rain. Okay, so this is another application. Same as here, that is the same. Okay, now these are the uses. Now let's look at another phenomenon. It's more like a geography discussion. So weathering and erosion. Now here, the most common question is, what is the difference between weathering and erosion? What is the difference? Usually we will use these terms together. Whenever we say weathering, we also talk about erosion. But a lot of the times we don't know what is the difference. Okay? So now, right now, similar to previous parts, I'm going to play a video. And from there, I will substantiate a little bit, I will explain a little bit, and then after that, we will go back to the notes and then we jot down some keywords. Okay? So let's have a look at the video.
This is Earth, home to 7 billion plus people, 7 continents, and all kinds of amazing plants and animals. This is what Earth has looked like for a long time, and will probably continue to look like for a long time, right? Yes, and no. Sure, this is what Earth looks like from space, but even though it looks pretty much the same from whenever we view it from afar, once you zoom in on it, you can see it's always changing. On a small scale, things like moving water shape the Earth's landforms, the natural features of the Earth's surface. On a bigger scale, the gradual shifting of the Earth's crust is slowly moving even bigger things, like the oceans and the continents. So one day, our planet will look different, maybe a lot different from how it looks now. So how exactly does water shape Earth's landforms? Or to bring it back to the spheres we've been talking about, how does the hydrosphere affect the geosphere? To understand that, we need to discuss weathering. I'm not talking about the weather, like if it happens to be sunny or cold or foggy outside your window right now. I'm talking about weathering, the process that takes place as rocks and other parts of the geosphere are broken down into smaller pieces. Weathering can be caused by water, air, chemicals, plants, or even animals, including us. And there are two types of weathering you need to know about: mechanical weathering and chemical weathering. Mechanical weathering is the process of breaking big rocks into little ones. Frost, ice, the roots of plants, running water, or heat from the sun can all cause mechanical weathering. Chemical weathering involves the changes that some substances can cause in the surface of the rock that make it change shape or color. Things like carbon dioxide, oxygen, and acids can all cause chemical weathering. And when rocks have been weathered and all broken down and are later moved by natural forces like wind, water, or ice, that's called erosion. Weathering and erosion sound pretty similar, right? Well, yeah. But not exactly. Think of weathering as the hammer that breaks down the rocks. Erosion is the process that carries those rock fragments away, or put in a way we're all familiar with. Weathering helps make a mess, and erosion helps clean it up.
Okay, so a very short video, basically discussing what weathering and erosions are. So the key question is, what is the difference between weathering and erosion? Now, if you go back to the definition over here, so weathering, we are talking about breaking down. Okay, the key words for weathering is breaking down. So basically, it breaks down large stones, large rocks into smaller pieces. And this process is called weathering. Now, what about erosion? So erosion, if you look at the definition, the key word is movement. So we are talking about after the large rocks has broken down into smaller pieces, then the smaller pieces will be moved from the original place to another place. It could be done by a lot of different ways. Probably the wind who blows the small pieces away, or the rainfall who flushes the small pieces away. So there are a lot of different ways. So you see the key difference between weathering and erosions is weathering, we are emphasizing on breaking down, but erosion, we are emphasizing on the movement. We are moving the smaller pieces from one place to another. But no matter it's weathering and erosion, there are similar factors that can speed up the two process, like the rainfall, gravity, wind, or action of animals and plants, acid, blah, blah, blah. So all of those factors can speed up the weathering and erosion, okay? So here, basically, weathering, we are looking for the keywords, which is break down. So we break down large rocks into smaller pieces. So weathering is the process of making big things into smaller things, okay? And erosion, the key word is move. Okay, we try to move the smaller pieces away from where it's supposed to be. Okay, so that is the key difference. Okay, now both processes can be sped up or can escalated by gravity, running water, waves, ice, wind, a lot of different factors. Now these are all the physical factors or the mechanical factors. That means they are not involving any living things. But you know from the video, animals and plants may also speed up the weathering and erosion, okay? Now, down here, there are some graphs showing you one of the very common process that leads to weathering and erosion. So here, this is a rock where there is a little crack or crevices. So when there is rainfall, some of the rainwater will be collected there, okay? And when it is winter and the temperature gets cold, so the water may freeze. And according to your common knowledge, common sense, you know, when water freezes into ice, it expands, it becomes larger in volume. So when they expand, they will make the crack even larger, okay? So when the crack gets even larger, it will further damage the structure of the rock, and probably this part of the rocks at a certain point will break and then shatters, and most importantly, it will roll down, okay, down the hill because of gravity. And probably the rainfall or the wind will play a part in moving the large rocks, okay, moving the smaller pieces, right? So this one is an example showing you how weathering and erosion can be speed up because of the rainfall, okay? Now here, freeze, and then you see, after repeated freezing and thawing. Now thawing basically means you change the ice back to liquid. Actually, if you don't know this word, you can use melting, okay? Okay, basically it's the same thing, all right? But it takes a long time, of course. Okay, now here, limestone caves are formed by weathering and erosion. So limestone cave, I'm not sure if you have seen one of these. So basically they are caves that is originally made of mainly limestone, but because of the weathering and erosion, so those rocks got deteriorated, and at the end they form a hole. Now, I will have another video just now to show you how it looks like, and it's actually quite a beautiful scene. It's actually some of those becomes a pretty hot tourist spot.
High in southeastern New Mexico, within the Guadalupe Mountains, are 46,000 acres of wilderness. Here, on an arid plateau, water, seeping and trickling drop by drop, has over eons created lavish formations in limestone caves. Caves formed by sulfuric acid dissolving the rock deep underground. A cave of strange, often bizarre beauty. Carlsbad Caverns. Stalagmites rising from the floor like petrified fingers. Stalactites from the shadowy ceiling, 250 feet up, biting down like gigantic dragon's teeth. These have been created by eons of slowly dripping water. Each drop laced with calcium carbonate. It can take thousands of years to add just 1 inch.
Now, going back to the notes again. So here we say that rainwater, okay, rainwater is actually slightly acidic. Okay, I'm not sure if you know that. And if you talk about pH, the rainwater is around pH 5.6. Okay, it's slightly acidic. And the reason why it is slightly acidic is because carbon dioxide dissolves in rainwater to give carbonic acid. Carbonic acid. So you can put down this word equation. Carbon dioxide reacts with rainwater, basically water, to form carbonic acid. Okay? All right? So you can tell, actually rainwater not only physically smashing, physically, grinding sort of the rocks, but also its acidity will also speed up the weathering and erosion. Okay? Now here, calcium carbonate reacts with carbonic acid to form soluble calcium hydrogen carbonate. Now if you remember, this guy is water soluble. If you go back to the calcium cycle at the back, if you remember, calcium carbonate is insoluble, but the calcium hydrogen carbonate is soluble in water. So that's why the rainwater containing carbonic acid can speed up the weathering and erosion. Okay? Now the word equation here, so you will put down calcium carbonate reacts with carbonic acid, okay, to form calcium hydrogen carbonate. Okay? And make sure you know this one is insoluble. This one is soluble in water, of course, in water. Okay? Oh, and again, let me also give you those chemical formulas if you are interested. So carbon dioxide, CO2, water is H2O, and carbonic acid would obviously be H2CO3. H2CO3. Okay? Calcium carbonate, of course, calcium carbonate CaCO3, carbonic acid just now here, H2CO3, and the product here, if you remember, very complicated, like this. Okay? So you can count the number of calcium atom, hydrogen atom, carbon atom, and oxygen atom. It should be all balanced on both sides. Okay? So that would be something to do with weathering and erosion. Okay? Make sure you know the difference between weathering and erosion. Okay? All right, I'm sorry, there was a technical problem where part of my video was not captured. So right now here, you see I have already jotted down some notes, but don't worry, I will again go through it. So now in this page, what we are doing is we try to think about a chemical test to prove that calcium carbonate is actually calcium carbonate. Okay, we want to prove that the calcium carbonate consists of calcium and carbonate. Now, actually, we did something similar in the first term, where we need to think about a chemical test to prove that sodium chloride is actually sodium chloride. Okay, and you know sodium chloride, NaCl, we can classify it into two parts. We can have a metallic part and a non-metallic part. So sodium is the metallic part, chloride is a non-metallic part. Now, if you want to test the metallic part, we are going to use a flame test. We want to look for golden yellow flame. Okay? And if you want to test for the presence of chloride, then we have a silver nitrate test. Silver nitrate test will give a white precipitate when the sample contains chloride. Okay? So like this is what we did before. So now we are going to do very similar thing, but this time it is calcium carbonate. So again, this calcium carbonate has a metallic part, which is the calcium, and the non-metallic part, which is the carbonate. Okay. Now the metallic part, again, we will do a flame test, and we are looking for brick red flame. Brick red flame. But for the non-metallic part, so we have another test. Actually, we did talk about that last time, which is to test with dilute hydrochloric acid. Dilute hydrochloric acid. Okay, that experiment with two test tubes, right? And we try to tilt one of the test tube so that we drop the calcium carbonate into the hydrochloric acid. Do you still remember? So that one, this test, we don't have a specific name, so we simply put down test with dilute hydrochloric acid, and that's it. Okay. Now down here, basically, some revision. We try to first do a flame test, and this is the outline of the flame test. Hopefully you take it as a revision, and we are looking for brick red flame for calcium. Okay. And remember, for flame test, the acid that we use is concentrated hydrochloric acid for cleaning the flame test rod. Now for the test for carbonate, do you remember this two test tube setup? We have one test tube containing dilute hydrochloric acid and the calcium carbonate, which is not yet dropped it into the acid. And then another side, we have lime water, and we try to transfer any gas produced from the left to the lime water and see if the lime water turns milky. Now, as the reaction proceeds, as you drop the calcium carbonate inside, the reaction takes place, and you see vigorous bubbling, and carbon dioxide is actually produced, and then it is transferred into the lime water, and lime water will become milky very quickly. Okay, and over here you see bubbles being produced. Okay, now we will say that if the lime water turns milky, that means carbon dioxide is produced from the reaction between calcium carbonate and hydrochloric acid. And if the sample, calcium carbonate, reacts with hydrochloric acid and gives out carbon dioxide, then we can say that the sample contains carbonate, okay? Because carbonate reacts with acid to form carbon dioxide, okay? So this test can be used to find out whether a sample contains carbonate or not. If it does not contain any carbonate, then it will not give out carbon dioxide. Then the lime water will not turn milky. Okay, so that's the idea. Now this is the outline of how we can carry out the experiment. Sometimes in exam or test, we may ask you to outline an experiment. Outline. Outline means, okay, outline. Outline means you very simply describe the experiment. Usually for outline, we will use a verb. We will use a verb to start a sentence. This one I think is called imperative. I don't know. So basically tell people what to do. Okay. Now down here we have two word equation because in this particular test we have two chemical reaction going on. First of all is the reaction between calcium carbonate and hydrochloric acid. And then the other reaction is between carbon dioxide and lime water. Okay, both of these equations you need to know how to write down. Okay, now last time, sorry, not last time. I mean, when I was having that technical problem, I have wrote down already. So here, calcium carbonate reacts with hydrochloric acid to give calcium chloride, carbon dioxide, and water. So probably you need to pause it and then write it down. Okay. Now here I try to also give you the chemical formula. Again, chemical formula is not necessary in Form 3 chemistry, but if you are interested, or actually the chemical formula, if you understand those, it could be very useful when it comes to writing down word equation or predicting products. So here calcium carbonate reacts with hydrochloric acid to form, now let's talk about carbon dioxide first. CO2 la, and then water, H2O la, no doubt. Now you can try to look at the reaction in this way. So you see the H, okay, from the HCl will end up in the water. That makes a lot of sense. The carbonate, okay, the carbonate, one of the carbon and two of the oxygen, okay, will become the carbon dioxide. Okay, that makes a lot of sense. Okay, and then you see because there are three oxygen, right? And actually one of the oxygen will be here. Okay, will be here. All right, so that makes a lot of sense, right? Now you see, right? You say, sir, there are two hydrogen here. Oh, so actually, okay, we need two HCl to react with one calcium carbonate. So actually there is a 2 here. Okay, it's kind of hidden. So the hydrogen is balanced actually in this case. And lastly, what about calcium chloride? Basically we have to look at what we have left. You see, we have Ca here. Okay, we have chloride here, or the chlorine atom, and there are two of them. So the calcium chloride here will very likely be CaCl2. Okay, so you see, once you look into the chemical formula, actually it makes a lot of sense, or at least you can tell how the atoms from the reactant ends up in the product. Okay. Anyway, this is additional. It is not necessary. Okay. Now down here, carbon dioxide causes lime water to turn milky. This reaction actually we have learned it. It is basically carbon dioxide reacts with calcium hydroxide. Because remember, lime water is basically calcium hydroxide solution, right? If you go back to here, you see carbon dioxide in calcium hydroxide solution. We did talk about this last time, okay? So just quickly put it down. Calcium hydroxide reacts with carbon dioxide to form calcium carbonate. Calcium carbonate. This is why we have the white precipitate. because calcium carbonate is insoluble in water. Also, there should be water given off. Okay? So that's the idea. Now again, all these word equations, I usually use a box, okay, to enclose those word equation, because you will expect to see in Form 3 chemistry, we will ask quite a lot of questions related to the word equations. So make sure you are very familiar with those. Okay, so yeah, that's that for Unit 4. Okay, so I will stop it here. Bye-bye.